Today we're going to talk about character animation technology with Bobby Angelov. So Bobby, why don't you tell people what you do for a living and what's your obsession with character animation?
Well, I started with animation at IO. Primarily, I was working as a generalist AI program, I guess, back then. And I got into animation, and I was lucky enough to work with Michael Butner, who really kind of got me into that. I got a lot of new tech and lots of exciting new stuff to try out and things like that. And I moved to Ubisoft after that, and I was working primarily in animation there, worrying about productivity issues, production, time constraints, kind of getting stuff moved from one system to another. Mm-hmm. A lot of these kind of more production-oriented stuff than the high techs. And yeah, now I'm moving on to a new position, and I'm still very interested in the field. And I'm also very interested in kind of tooling and technology that can make life easier for both animators, programmers, QA, everything. Yeah, and I guess this talk is just to kind of sync up on a few topics that we've been chatting on Twitter about.
That's right, yeah. We got into arguments, and with 140 characters, it didn't really...
Yeah, it's been a nightmare trying to track the threads.
And I'm Alex from AiGameDev, and well, most of the time that I spend these days is organizing the Nuclei conference, and some of the stuff that Michael Butner's working on is actually going to be featured at the conference in July. So I guess, was that the starting point for the discussion, or was it something motion graphs related? I can't remember.
It was a starting point about me not being able to read a paper.
Oh, that's right.
Like I couldn't, good old academic garbage.
I'm gonna have to beep these parts out of the recording.
Well, it's not the academic part, it's the garbage, it's the way it's written. It's almost impossible to decipher. And when you finally spend the time to do it, you realize that all the important information is missing. And then you're like, well, this is a complete waste of time.
Yeah. So I worked on the kind of systems that you were reading about in 2004, 2005 at Rockstar Vienna. And a lot of that tech made it into the Rockstar Table Tennis and the shared engine that Rockstar was building at the time, and that's gone through many, many changes since then. I'm not sure how much of that they're actually still using. And so I've spent quite a bit of time with that low-level animation tech and working more on procedural stuff just for fun recently. I think it keeps the skills fresh to write procedural, like code-based movement of bones is an interesting problem. Okay, so we had a lot of disagreements about terminology, or let's say miscommunications about that. So maybe we should start with that side of things, and we'll see what parts we agree on. I wonder if we should start with like the stuff we definitely agree on, like low-level stuff like blend trees and things like that.
Mm-hmm.
I'll have to drag this thing out of it. Okay, so blend tree, I guess, is a typical root node with lots of sub-animations. So the leaves would typically be like these raw motion clips, right? That you could be blending between, or...
Yeah, in some cases, yes. Primarily, there'll be animation sources.
So stuff that's been cleaned up mocap for animations.
Yeah, or single frame poses, or even procedural adjustment poses, that kind of stuff. Yeah. Basically, anything that is a set of bones that refers to some sort of animation pose.
So these branches in the tree would be things like, blending as a generic term, but things like continuous mix or cross-fading or any blends. Combinations. Yeah, they're all types of blends, I guess, but I'm just trying to...
I think people overcomplicated the blending thing. Like, it is just fundamentally a blend, and the only options you really have there is do you do it in local space or global space? Is one bone done in global space and the rest local? And the other thing is whether it's additive or interpolative. Those are the only two real options, and everything else is a variation of that. A lot of the really fancy stuff is just controlling the blend parameter.
So additive, or what was the other? Interpolation?
Interpolative.
Okay.
That's the standard one. It's the one where you just interpolate the rotation and translations. I don't know what the correct term is. I just call it interpolative.
Well, you can do interpolation by adding weighted bones together, right? So you just change your weights, can't you? So are these two kind of similar, or do you have special code paths for them?
But if you add the two bones, what, the positions or the
Well, if you have two frames like half like sitting aggressively and sitting relaxed, and if you blend between the two with 50-50, that's like interpolation, or
yes,
like adding 0.5 of one versus 0.5 of another is the same thing as interpolate.
No. Additive is something like you would have a base pose and you'd have like a modification on top of that, which is extracted at authoring time. So you would imagine you would have an aim pose like this, and at authoring time you would do a bunch of different aim poses, with offsets.
Yeah.
And what you would do is you would extract the offsets into simple additive offsets off a base pose.
Oh, I see. Okay, yeah.
And at runtime you would add that on top. It's very useful for example, you have a single pose for holding a machine gun, and then all the different types of machine guns, you would adjust the fingers and you would adjust the hand offset slightly.
So isn't that another type of like blend, almost like relative to the current position?
Give me a sec. Double just rang.
Go ahead. I was hoping we wouldn't have to edit this, but I guess I'll probably have to cut this out. So I like to use different words for blending to clarify what's going on, because it's different. It's the same code, but it's different purposes. Things like cross-blending or cross-fading, I guess.
Sorry about that.
No problem. So I was just saying that I actually use different words for different things because they help. Right, continuous. I think they help explain what's going on in the tree.
I guess, but they can also be extremely confusing, because then what ends up happening in implementations is you have 25 different blend nodes that are all slight variations of the same thing, and it becomes a nightmare trying to debug that giant mess.
Yeah. Well, you still need to have like cross-fading will have different parameters than mixing. So I guess either you have one single node type with lots of parameters.
You don't need to in reality. For my animation graph, I simply have a single blend node that takes in a blend weight.
Okay.
And it takes in the parameter for whether it's local or global and whether it's additive or interpolative. And that's the only parameters it takes. And all of the cross-fading magic and stuff, that is simply just driving the parameter.
Changing the weight. Okay. So you have that. So you have some layer that sits on top of this, and then that controls all the parameters like weights. Excuse me.
Yes.
Well, basically just weights of each of the child nodes, right? So
I always believe that the graph is not a structure that defines everything. It just defines the animation part, the visual part.
Yeah.
How you feed in the weights should be abstracted out of the graph. That is something that's contextual information for the graph that belongs outside of it. It's the user knows about it. It's like an API. The graph is the API, and you need to feed in sensible information for it. Otherwise, you get garbage, which is like any other software system.
Yeah. So the trees don't really work on their own if you think of them as externally controlled. You have to have a minimum of logic to be able to get a crossfade. You can't just let the blend tree run on its own. You'd have to have a minimum.
Well, no, you would almost never do a crossfade inside of a blend tree, though. That concept makes no sense. That's why you would have state machine.
Oh, I see. So you're not handling that as
No, you're thinking of very kind of old school blend trees, like Unreal style, where they didn't have state machines, they didn't have hierarchies, they just had this giant tree that handled everything, and that's
I guess
bad way of doing it.
It depends on which way you think of it. If you think of one of these nodes as something more complex that could have its own internal state in it, and this is ultimately like the top level. This is like the final pose. So I guess that would be what you call the old school way.
That still exists, except that node would be something like a state machine node.
Right.
And then the crossfade at that point, I don't know if you would have a crossfade between two nodes in that case, but what you would do is you turn on a node and you turn it off again. Yeah, so and that would ramp up the weight and then ramp it down.
Yeah.
But again, that's not something you need a special node for. It's simply just saying, hey, I want to turn on the upper body layer, and I'm going to do it over.
Fade in. Well, that's right. Fade in the weights. Yeah. No. Okay. So I think the the advantage of keeping that data structure completely separate is that you can implement it like more memory efficiently, not have all these all the indirection and the higher level logic is separate, and then this blend tree becomes a relatively simple data structure that you can traverse super quickly.
Exactly. I think in reality, most of my runtime state for the graph, even for the complex ones, is 10, 20K. It's not massive at all for like a full thing. And I've done so many iterations now of the same thing that you can minimize the active working set very significantly.
Yeah.
And the bulk of the code and the bulk of the content is still, it's game code. It's not animation code. The animation problem is relatively simple if you isolate it out from all the design and the game. Mm-hmm. And I think this is a mistake a lot of people still do. They put a lot of game logic inside of the animation graphs. And they end up with these pseudo gameplay state machine, anim state machine systems, which, they become hard to control.
So we have a blend tree layer. And so down here, it would basically just be a... do you consider the tree like mostly... it is dynamically changing as you insert and remove nodes, or do you consider it to be static, or how do you approach them?
In my case, it's static. It's static in the sense that you would specify where dynamic nodes can be plugged into. Okay,
and it's similar to a behavior tree, I guess, where you have a lot of injection points, and you say, well, I would like this behavior to come in at this priority. Okay.
Well, there's no priorities. It's just saying, hey, this layer here or this node, I will set at runtime. I don't know what it is, so you'll have something like your base and your upper body, and then the upper body will be plugged in at runtime based on what you're doing. Yeah. Simple example like that. But you would define explicit points where the stuff comes in, so you can control the blending in of those. When do they come in? When is that active? When is that node not active? It's these kind of things. So fundamentally, the tree is all static.
Mm-hmm. And then, so you're basically just rewriting certain of these branches in the tree, but they're pre-allocated. The new trees that you're injecting dynamically, they already exist somewhere else.
Yes, there's no actual there's no memory allocation, nothing, because the trees are static. So you just instantiate the memory, and all that happens at that point is you just have to point it to the new tree, and it executes as if it was part of the original tree.
Mm-hmm. And then the result of this just goes straight into the graphics. There's no extra. You could have, I guess, IK nodes, but those would be part of the tree as well, right?
Yes, the IK nodes and the procedural offsets. This is something that I strongly believe in, is procedural nodes, stuff that does bone offsets, bone modification. Anything to do with modifying the pose needs to be in the blend tree. It needs to be a lot of people will potentially run an anim graph, and after that then fuck with it by modifying, doing foot IK, or adjusting hand positions, or changing the aim vector. These kind of things. The problem with that is once you have a bug or you have a bad pose, you don't know where it's coming from.
Yeah. It needs to be state specific as well, right? In certain states you might not want that.
You'll see code in like some magic gameplay code saying, well, if I'm in this gameplay state, then once I get the animation out, then play with the bones. And then you'll get an animation bug saying, well, the animation system's broken here. And you're like, by the time you figure out that it's not the animation system, you've wasted a day or two. And this kind of stuff fundamentally has no reason not to be in the graph. I just think it's not very commonly seen. For example, my graph only has 4 parameter types: booleans, floats. What else do I have? Ints or enums, like state values, IDs, and transforms. So I feed in full transforms into the graph. Yeah. So for example, if I want to do a bone modification, I can just feed in a transform saying, hey, modify it with this transform. Or if I want to do an IK target, I feed in the target directly. Yeah. So again, it simplifies a lot of the blend tree code, because you have the transforms directly after any manipulation. Yeah. But it pushes, you still have the gameplay code feeding in the target values. The only thing is now you can see it in the graph, or your debuggers will pick it up. It's a lot simpler to work with. So if we're whilst we're on the topic, the idea of a runtime rig is basically taking
a blend tree, but that works in rig space instead of working on individual low-level bones?
This is something that I was very interested in when I was talking to the Destiny guys, and I was looking at that because different companies have different terms for this runtime. For example, Morpheum had that term years ago.
Yeah.
And it was just their animation skeleton, right?
Yes.
And I talked to the Destiny guys, and fundamentally their approach isn't very much different to what we regularly do. The only difference is they have a much higher compression rate for their animations. I
think part of that comes from the fact that they're not driving all of the bones, so the knee bone is driven by the fact that the foot is set up as an IK effector.
They do drive most of the key bones, which is what we do with the animation skeleton.
Right.
Now, there's also this confusion that a lot of companies maybe don't have the distinction between animation and graphic skeleton. Yeah. So you would have two skeletons fundamentally. One would be a pure animation skeleton, which would be the focal, the key joints that you would care about in terms of the pose, which is sort of the runtime rig. It's a good program art over there.
Yeah, check this out. It's amazing.
And then you would have the graphic skeleton, which would be the same thing, but
more bones. Yeah, I mean, in graphics, you need like 5 different bones in there, or however many in the shoulder, just to get it to look good.
Yeah, you'd have the twist joints, you'll have the aim constraints, you'd have a lot of these kind of things just for skinning, which are completely irrelevant to animation. And Destiny, I think, that's what they're claiming, is that they're using the constraints to solve those skinning joints.
Yeah.
You know, like a mesh skeleton in general, you'd be looking at something like 200, 250 bones these days for an average character, whereas an animation skeleton could be, you know, what is a good number? 60 with all of the toes and fingers and stuff.
Yeah.
You know,
ours was 58 on Max Payne 3. I remember that one. Just the core.
The Destiny guys are still recording the finger bones. So their runtime rig is smaller, but they're still getting finger poses from somewhere. They have to generate those.
Yeah, but so for things like you can get the knee position, for example, just by setting up an extra effector on your the foot effector. You can say, well, this is the rotation I want. You can calculate this, so it's basically a form of compression. There's a like an analytical solution for calculating the knee position, knowing the foot position.
Yes, there is some joints that you can infer, but once you go to non-humanoids, like Destiny has, I'm sure those rules go out the window.
Well, as long as it's 2 bone IK, right? As long as they have legs with... Do they have legs with 3 bones? I guess that's the question.
I don't know. I can't quote, but imagine you have a robot that has, let's say, some kind of a machinery arm, like a telescoping arm.
Yeah. Well, they'd have to set up a hierarchy of like 2 times 2 bone rigs, and then that becomes a...
with different constraints for the specific character, and it becomes complicated. And the reality is, this technique is useful for saving memory. And that's not such a massive problem anymore on next gen.
Yeah, so with well, for example, the hands, you could compress that hand sub animation at a different time sampling, right? You don't need necessarily 60 frames per second to capture the hand movements.
Depends if you're first person or third. If you're first, no, you can't.
Yeah.
Because that hand's right up in your face, and you see all the pressure out of it. Which is something that bit us in the ass. Like, you know, you don't think about that. You say, well, this looks great.
Yeah.
I can see it in motion. Well, it's great. You see it in game, and you've got jit on the hands.
Yeah. I was third person, so I didn't worry so much about that.
Yeah.
I think in third person, you could probably get away with like just a few key poses, and you know. Yeah.
Most of the time, in third person, you can get away with murder, but in first, it becomes very problematic.
But then the advantage of first person is that you don't have to worry too much about the foot placements at all, and you just have arms there, right?
Unless you want shadows, and then you have a whole nother headache. Because, you know, if you want to generate proper shadows or body awareness, then that's another massive headache. So yeah, fundamentally, this split doesn't seem as common as you'd think. And I think this is why a lot of people like
Yeah, I
You
think
know, I've
that.
seen guys animating on the mesh skeleton. You know, they'll be exporting 240 bone.
Yeah, but I think that's why there's generally a lot of excitement about this kind of approach, and from Bungie and Ubisoft Toronto. Also, they have a talk at Nuclei about their version of the runtime rig. They call it an IK rig. So I presume they're similar ideas. But what I like is that it sets a nice level of abstraction. You don't have to worry too much about the low-level details. And if you do want to control the fine details of the bones, then I presume you could just throw in some kind of post-process. But I'm not sure if they want to allow that. I mean, just the idea of having that level of abstraction between the two seems very healthy, and just not exposing certain bones is a good thing.
My primary question regarding that approach, and I never got a clear answer on this, I couldn't find an animation programmer to answer this, is how would you do blending on the Destiny approach? Because the bones aren't... What I understood initially was that the bones weren't in local space, that they were all parented to the root.
So I think it's the same as what you were explaining earlier. They have blend options. They can specify this should be blended in global space, in local space, or relative to the object that current thing is attached to. For example, a hand grabbing onto a car. So
But the question is, what is it exported in? That's the primary issue before you get to blending, is what is this exported in? Let's say all of the joint positions were exported relative to the root.
Yeah.
How would you blend that without having hierarchical information? Because if you do a linear blend between positions or rotations...
Well, they've got their own tools. They've got their own tools pipeline, and that's what they were showing at GDC this year.
But that's authoring pipeline.
Yeah, but then they have the information to export. They can say, blend this additively in local space, or blend this thing in global space, aiming at this exact point. And so they can specify that. And I guess that as long as the tools give them that form, that way of expressing things.
Maybe I misunderstood something, but talking to the technical animators, that's not the reality of it as much. A lot of that is authoring time, and then they export an animation and they use it in a relatively standard way. The question I had was, if these points are exposed in global space, you can't really blend them because you're missing hierarchical information. You can't just do linear interpolation between the positions. Slurps. You need the parenting. Otherwise, you'll break the constraints. And if you do have the constraints, even if they're in a separate form, then you fundamentally come back to having a hierarchy.
Yeah, I mean, I'm sure they have the hierarchy, right? So they have this here, like for the leg. Whether they have the knee as an extra bone in there or not, I'm not sure. But for sure they have this piece of hierarchical information, and they have this as well. So that information is there. And as far as I know, I think they basically presumably have shoulders as well.
Which basically means that it's just fundamentally, tech-wise, you can boil it down to a compression technique, a very elegant one.
Yeah. Well, I think what gives it this flexibility is that there's more to it than just compression, because you can specify things how to blend in local and global space.
You can do that on a regular skeleton.
Well, it's harder unless you assume that there's going to be an IK post-process for it. So
which they do.
Okay.
They always have IK post-processing.
So in this case, that's the big difference, I think, with Bungie's system, is that they have this always-on IK. They assume that it is always there, and I think that's the big difference between what we were drawing earlier. Well, that's a very different scale. Where we're drawing here, like IK becomes this kind of extra post-process in the tree. In Destiny, they basically say, well, this whole thing is always going to be wrapped in an always-on IK, which I think is that's kind of it helps build better tools when you have that assumption.
Yeah, I spent a lot of time because I thought this was finally something new and interesting, and I couldn't understand it at first, and maybe I still don't understand it. So maybe I'm talking out my ass here. Potentially, yeah. But looking at it, I don't see anything that it brings to the table that we can't already do, apart from the compression, which I think is very elegant.
So some of the good example. Have you seen the talks from GDC?
Yeah, I saw the SIGGRAPH ones and I saw the GDC ones, and I managed to get a chat with one of the guys at GDC.
Yeah. So they one of the examples they had was sort of like aiming. If you do aiming with additive motion, you can never fully get the aiming right, because you'll get, like, as the hip moves, you get like the additive motion will. You can't do that without IK and having that IK post-process. Right, so if you want to do aiming with an additive motion, then it requires an IK post-process. In which case, you might as well just do it with IK in the first place and just animate the IK effector and let that do it. So they're basically cutting out a whole part of the pipeline by all this the fluff that they have in the middle of having to take the original motion, then layering on top an additive aim, then post-process correcting that with IK. Instead, you get rid of that and you say, well, here's the skeleton, here's exactly what aiming should do as an animation relative to this object that's being pointed at, for example. I presume, aim at is one of their IK solver modes. So it doesn't do anything revolutionary, it just makes a lot of things super, easier.
But they had some significant limitations. If you look at their talk, they actually said in the talk they have a lot of limitations in terms of what they can blend, what they can do with that system, and that is the part that worries me a little. Yeah, is that they said at the end, there's a caveat that's great in some cases, but we also have all these problems. Yeah. I can't remember off the top of my head what they were, but there were some relatively big ones.
I think. Well, does it come down to this abstraction
I can't remember. I think it's more to do with their runtime about changing poses and something like that. Like, I can't remember, so I'm not going to comment on that. Yeah. But there was some significant ones at the SIGGRAPH talks that they mentioned at the end that they couldn't do. And the additive stuff they have for the stability is really great. Off the top of my head, I'm trying to remember now exactly what they were doing. But yeah, there are some benefits, but you can again solve these. Yeah,
sure. I think we agree that we can still do the same things we could do before. It's another form of abstraction that helps you solve. I mean, especially in their case, it helped them solve a large number of animation problems, including like supporting lots of different humanoid types of different proportions.
I think the strength of their pipeline was the tooling. I've never seen a better authoring tool set than what they have. Their stuff blew me away at GDC. Their authoring toolkit is just insane.
With the Python scripting.
Yeah, well, you don't have a choice about what scripting language you use to order their stuff, really. But just the toolkit and the elegance and how they built it, it's very sensible and it's very smart. So how you export, they could have done it with a regular system and they would have had probably similar results.
Well, I think it would be much slower. I mean, once you've made the assumption that your IK is going to be always on, you might as well just export those things in IK space or runtime rig space, as opposed to baking low-level bones. I mean, that's sure. Okay, so I think we've covered that topic. I think we agree.
I think past export time, it's an arbitrary choice. The tooling to author the animations, they have some incredible things there, especially the reparenting of bones. Yeah. That fundamentally only makes sense at authoring time. And it's excellent because you can't really do that in stuff like programs like Motion Builder stuff very easily. Yeah. So, but yeah, that was one of the only new things that's come out recently.
Well, I don't think we really need that much new stuff. I mean, I think it's getting pretty mature in terms of technology. Well, I mean, apart from things like muscle deformations and all those types of things, but those are like additional bones and blend shapes and those types of things. But
you'd be surprised how behind we are in terms of animation tech in a lot of AAA engines.
Behind who?
Well, Morphine 5 years ago, for example. Yeah. Like Morphine 1 even. There's companies that don't have any of that. They don't even have hierarchical state machines. Like look at Mechanim for Unity. Mm-hmm. It doesn't have the concept of a hierarchical state.
So I was thinking more about the low-level stuff. It seems like this layer is super mature and we have a pretty good handle on it. Okay, let's talk about the higher levels then. Shall we first talk about like what sits at the top and then draw the level in the middle afterwards? Or
Sure. We can do that.
Are we talking for players or NPCs, or shall we split them up? Or do you think we can?
I think in terms of animation, the problem is very similar. The only real difference is how often you update the animation parameters. Mm-hmm. A lot of times for NPCs, you have more latency because you can actually have them play a canned animation, which you can't with the player.
And NPCs will know a bit in advance as well.
Exactly. They have a lower frequency in the updates, whereas with players you need to respond to stick inputs. So fundamentally, tech-wise, I think it's similar, and that's the approach I've always taken: is to build a I don't know what you call it, animation behavior level or animation programs or something to sit between the game code and the animation system.
So I think there tends to be like the slightly different information where you're talking about AI or players. Like AIs will typically, like, whereas with a player you tend to just be able to specify things like relative movement and like speed, I guess, or certain accelerations. Like with an NPC, you know where you're going. So that gives you some flexibility, but then there tends to be some adjustment in the actual trajectory at runtime for avoidance, right?
That's true for players as well. Imagine actions like climbing a ladder or canned animations like going into cover or jumping over something.
Yeah.
Those are the same as for player or for NPC. You still have displacement adjustment, you still have anchoring, you still have all of the NPC things.
All right, so both of these things get passed down into the same interface, into this low-level system.
Yeah.
Okay. So we're talking about specifying where you want to go and adjustments to that type of motion or the direction of the motion and the speed of the motion. Okay, so the bit in the middle, I've left very little space for that. I'm going to start a new slide.
Well, usually those intentions is like what I like to call them for the NPCs and the player. Get processed by separate programs for the actions they're in. Sort of like Destiny had the concept of action programs, I think, or actions.
I don't remember the name, yeah.
It's the same thing that I have is called animation behaviors. It basically takes the intentions and translates them into animation commands like set this blend weight or trigger a transition or ensure that you're in this state. And that is the knowledge that ties the game code to the animation script. That's your code data dependency there.
Yeah.
And those programs would take, let's say, a player's velocity from the stick, filter it potentially. Ideally, that should be done in gameplay, but you take that input, you would convert the format, and you'd feed it to the animation system and get that result. For the NPC, you would again do the same thing, except you'd get back the displacement, and you'd usually do some modification on that. Ideally, again, any displacement modifications would be done as part of the graph, having something like a displacement correction or inside the graph.
So for NPCs, I call this layer locomotion usually. I mean, it does a bit more than that, but I group them together, like things like posture, control, and just motion in general.
Well, it does a lot more than that because all of the aiming, the environment interaction, all the weapon adjustment stuff, like, I'm holding an M4 versus an AK, I have to adjust my finger poses. All of that stuff happens there.
Posture. So this middle bit is, I guess, what you call the animation graph?
Yes, yeah. I would call that the graph. Well, there would be two middle bits. One would be the animation behaviors, the programs.
But didn't you say those were at the top or like up here?
Well, you would have gameplay at the top. You'd have the gameplay or the AI code at the top.
Yeah.
That would then feed into the animation program.
Okay, so we have a whole... we have like, for NPCs, that we have a whole layer of like behavior trees here. And then they feed stuff into this low-level movement manager, or whatever you call it.
Okay. Yeah, okay. Then that little controller picture threw me off because, the animation system should never even have a concept of control.
Okay, then I'm going to move it up here. So here so this would be what, like a player input?
Gameplay, gameplay, player control, whatever people term it. I think gameplay is the more common term.
Okay.
The animation, the whole point is to separate all the concepts out of like, I should be able to remove that top layer and still be able to fully test my animation system.
Yeah.
With absolutely zero gameplay and absolutely zero AI. I should be able to do a full feature test without anything. Exactly.
Yeah, okay.
And then below that is your
animation.
Whatever animation runtime you have, like hierarchical state machines or decision trees or whatever your system has.
Is animation runtime? I guess that's a good graph or. Well, it's
Yeah,
not.
some people don't actually use graphs. You'd actually be surprised how.
We got into that discussion on Twitter, but I think again we hit the 140 character limit. I think that that GDC talk about Watchdogs. So the impression I got was that they had some code here that was expressed as a complex graph, and over the course of the project that simplifies significantly. So that was the slide in the Watchdogs GDC presentation. So I understood it as being in this layer, but it's not. It's not. So it's the layer above.
I'm not sure how much I can say. What I can say is I think since they highlighted the GDC, so I guess I can talk about this a bit.
Yeah.
Not in detail, but it doesn't control animation. It boils down to sending animation commands in some cases, but fundamentally it's a gameplay state machine graph.
Okay, so the one up here, right?
Gameplay states. The problem is that it mixes in animation states too. So it's mixing, it's like you would write code traditionally, like years ago when stuff was simpler. You would actually say, when I change my gameplay state, I want to trigger this animation inside of my gameplay code. Mm-hmm. That's what that graph was defining. It was basically a visual form of your gameplay coding. So it was mixing gameplay events, animation transitions, gameplay transitions, interaction control.
Okay, so they've simplified both the gameplay in terms of going from one state to another and the animation at the same time.
I wouldn't use the word simplify, but yes, they had it all in one place. And this is what they moved away from.
Yeah.
Which I guess, if you want to say yes, it defines animation transition. So you could think of it as an animation graph. Yeah. But it doesn't actually define any animation commands or anything. It has no knowledge of animation. It just triggers transitions. It says, please go to the state, please go to the state.
So I'm just going to shift this over here. So it kind of stops roughly at this level.
Yeah, I guess it's like a high-level animation graph.
Yeah, okay.
It's a high-level transition graph, I guess. It's hard to describe what it is. Like I said, I don't want to talk about it.
Well, so what I found interesting is that that's something that I bumped into as well. And both high-level animation and low-level animation, you can bump into these problems like at the low level, specifically for things like locomotion movements, when you're blending between run forwards and strafe left and backwards, and then you end up with this like super complex state machine where like all the different options of like running forwards but facing this direction, and not all of them are going to be parametric motions, and many of them will have to transition into a different animation type. So each of these states will be their own parametric animation for, let's say, run forward, or actually, run forward with a speed control and with an angle control.
Exactly.
And so this gets really messy after a while. I think that's one of my.
It definitely can. It can not in some cases if you do it sensibly, but again, anything can get messy. And this is an argument that everybody makes about graphs and say, well, graphs will be a giant mess. It'll be spaghetti. And yeah, that's true, but I've seen spaghetti code. I mean, that's where that term comes from, right?
Yeah.
And everything can get messy. It's no one system is worse than the other. But yeah, fundamentally, you would end up having parametric nodes that would define a blend space. And then those will be blended with stuff like layering for upper body or transitions towards discrete actions. Like, for example, one example we did at IO was we would have guys running forward, which would be parameterized for direction and speed. And then at some cases, when you want to do a 180 turn, we would have transitions to 180.
That's right. And then you have like a special...
Yeah.
And then
okay, character needs to do a 180. And for AI, the AI almost never needs to do a 180 except for very special cases when path needs to be replanned or something major has happened. And then it's okay to do a quick 180.
Mm-hmm.
There's no need to build a huge parametric space and all this kind of logic. There is one benefit to doing it in a graph. It's visible. You can see exactly what's there and what's not. Yeah. You have your coverage right in front of you. And that's one big benefit over some of the, let's say, motion graph, motion field approaches. Like, it's very hard to do an audit and saying, do I have all the animations I need? How can I quickly tell? Do I have the full set of range of motion?
Yeah. Yeah, so your parametric turn animation, actually it might not even be parametric, right? The 180-degree turn?
No, it's not. It's a discrete animation, one for left foot, one for right foot.
Yeah. So we had some crazy variations for like 270, but I'm not sure that was worth it. Like,
why would you ever need a 270?
Well, because when you're in the halfway through the turn, you might want to sort of change the direction you're running in, and we found that you could get a bit of extra responsiveness by parametrizing your turn.
We always said that you could do a 180, but we cut off the 180 as soon as the guy had turned 180, and at that point he could then steer again.
So as soon as there's a foot placed or something,
then he could re-angle. So it looked more like a
So
like a curve.
We had I don't think it was 270, but a bit less. We had some mocap for those as well.
You can go crazy. That's the problem. Is initially you start planning the mocap set and you come up with all this crazy stuff. And then at the end, you realize, you know what, I could put all this animation in, and the end result looks the same as if I had like 2 turns. I know guys that would, for example, the forward motion, they'll do a run forward and then do a run left 90 degrees.
Yeah.
And then they'll say, well, if we blend, it's going to be crap. So we'll do a 45, and then we'll do a 22, and we'll do a 67. And the reality is the 22 and the 67 are completely...
Yeah, you don't know. So with good blending, and this is what comes down to the motion graphs paper. Like you really notice the difference if you do those kinds of things with a good like parametric animation created with a good tool, or with a an animator who's done a really good job of lining things up. But that's not super trivial to do if you have some mocap animation that covers these different.
No, it isn't trivial. Cleaning up the animation, I guess, is trivial. It's annoying, I guess. It's not fun work, but it's not hard to do.
Yeah, you just have to make sure all of these are lined up with like all the feet and stuff.
Yeah. Well, you just need the phases to be lined up, nothing else.
Well, you want your feet lined up, right? So if the foot plant happens, it should happen consistently when you're blending.
Yes, but if you have the phase matching, like you would mark up the phases for the feet, then it doesn't really... As long as you have similar amounts of phases, you'll be okay.
Yeah.
That's the other thing. The one thing I like about the phase matching is that you can have a cycle with, let's say, 8 steps and blend it with one that has 2 steps. And you would get like a nice variation of that, because each 8 steps was slightly different. You can get a lot of variation cheaply like that.
Yeah. I mean... I was very impressed with this part of the motion graphs paper. You apply that same tech to lining up all these motions. It does it takes a bit of time to get it polished, but it does a really good job of lining all this stuff up and creating like time alignment curves. So you have like, this is the speed of the first motion, and this is the speed of the second, and you need this T1 and T2, and you have to blend different times of each motion. And that part of the motion graphs, the parametric motion graphs paper, is super useful. I don't know if it's worth the time investment if you have someone who's willing and capable of doing it by hand efficiently. Then
by hand, it doesn't take long. It really doesn't take long. A good animator can whip out an locomotion set in something like 2-3 days from the mocap data, with the cleanup, with the adjustment and displacement, everything. And I would argue that you would need some of that work too. Even for the motion graph approach, because you still need to sort of annotate some things like foot plants, whatever. You can't generate those automatically.
I don't know. I don't know. So I think some studios are using automatic foot plants, and I experimented with it. I never got it reliable enough to use fully in production, but at least it's a good first pass type thing.
That's exactly it.
But I know there are some using it actually, this is what we used, and they make it sound so easy. Oh yeah, sure, we just did this. And I was like, what, how could you do that? I tried the same thing and it never worked for me. And so it's like black magic of getting a automatic foot detection to work.
Exactly, and the displacement as well. Like having a clean displacement out, it's not trivial to do. You need an animator to clean that up. And this is my major thing. I think the motion graph paper is awesome as an academic paper, but I'm not too sure what would be the benefit, let's say quality-wise, final product-wise, over a bunch of parametric nodes.
Well,
that are phase
the
matched.
difference is I can throw these motions together and get some results out of it once I have the tech, right? So it's a classic trade-off between upfront investment versus like if you're doing it manually, then you'll have to spend n amount of time for n motions, right? So this is like the time taken, and there's a number of motions.
I don't know if I understand that entirely.
Well, so if you build some tech, for example, it's like it's an upfront cost.
No, not that I completely understand. I mean, the fact that it's faster, like throwing all these motions. Which motions are we talking about? Because let's say for NPCs, I need just the forward parametric motion and the 180s, and I have 90% of my locomotions.
Well, so if you're doing like a third-person games, you need a hell of a lot of motions, especially like for games where the player's in the middle of the screen and the focus is on the movement. You'll need a lot of that.
Yeah, but you can't shove in stuff like the crouching or the going to cover into the same set of animation as the locomotion. You simply can't. You're gonna have a hell of a time explaining to the motion graph what your actual intentions are. Hey, I actually want to go to cover here. And I don't want to crouch. I want to not crouch and strafe left. I want to actually go into a cover motion.
Well, sure, but you still, you can't do that with that system. You have to build that. It's like the gameplay layer that we talked about earlier. Like you have these different states. You need to have those motions already pre-binned, and then only then do you pass them in to the whatever system you're using.
Exactly. So you have the pre-binned, and then you're defining transitions and gameplay layer somewhere above between the bins, right?
Yeah.
Which, my question is, how is this fundamentally different from having parametric nodes and transitions between them?
No, the result is the same. It's just the question of how you build them. Like in the case of using the parametric animation tech to line up motions, you're just using tech to build what an animator could build by hand. It just takes less time.
You say less time, but then this comes down to my other major argument is, in our experiments, at least with Michael, from what I remember, the similarity metric doesn't work as well as they claim it does. Because imagine you have a single pose and you want to check the similarity to 2 poses. And in the one pose, the left foot's moved slightly. The other pose, the right foot is moved slightly. Your similarity metric will be exactly the same. Yeah. Without any kind of semantic information about what is a better match in this specific case. Right?
Well, so what are you using the graph for? Are you using the graph like at this super top level? Or are you using it down here?
In the motion graph to pick the transition points. So let's say I have one pose that I'm trying to figure out what are good transition points. Without semantic information, for example, if I have 2 target poses where one's moved the left hand and one's moved the right hand, similar amounts, mathematically this could come down to the same similarity number. Yeah. And at that point, that might not make sense on the one hand, where if I'm on a left foot and my right arm swing, that doesn't make sense. Also, imagine the situation where you say, okay, for locomotion, we'll weight the feet higher, right? We'll put more emphasis on the feet. We want the feet to match up more. But then what if the guy's climbing, a monkey bars or something? Now you need a new similarity metric there. Yeah. What about going to cover? What about rolling? Yeah.
So I think you need the same kind of approach, right? You need to filter out what is a valid type of motion, right? You can't rely on the graph. If you want that kind of control, you can't rely on it. You have to...
exactly. And we need that kind of control, unfortunately, especially for character control. Yeah. Like, we have so much capability, like jumping over things, climbing things, interacting with the environment.
So tagging things would help, right? So if you just said whatever the file name, if it has run in it, then we can use it at this stage.
Yeah, trusting naming conventions for that is a little bit dangerous. Especially when dealing with legacy data. We always have that legacy problem. You have data, this massive amount of data from previous games, from previous titles that is excellent data. It's perfectly mocap from 5 years ago. People haven't changed how they walk. It's still valid data.
Yeah, if it's good enough quality, I'm fine.
Yeah, and this is the question is now, if I have to build a new similarity metric for every single sort of action I'm trying to build.
No, I don't think you do it. Yeah. Yeah, so you couldn't get it working?
Yeah, because you would get poses that were very similar mathematically, which was entirely correct. But visually, they didn't look right.
Yeah, no.
And
So if
the upper body, it becomes complicated because
Sure.
the feet sort of match up a little bit.
Yeah.
But the leaning, like guys leaning a little bit to left, he's leaning a little bit to right. It's very hard.
Yeah, you get things like momentum that doesn't transfer well when you pick transitions. Yeah, like that video I showed you. You can tell the momentum differences in the transitions.
And my main concern with this approach in general isn't so much the tech. I think the tech works, and I think you can, with a lot of effort, get to that.
Yeah.
The problem is that I see is once you get close to shipping and you want to polish this, you're going to be in for a hell of a time, because you start playing with that similarity metric, you're going to incur a lot of problems.
Well, by then it's too late. I mean, if you've reached that stage, yeah, it's the standard argument of tool versus do it yourself manually kind of thing, or machine learning, for example.
I think with a graph you have the compromise that you can do it fast enough, because you still have to manually annotate things, which you would do in the motion graphs approach. You can't get away from that, really.
Yeah.
And once we come to polish, I could sit there for an afternoon and try tweak it.
Okay.
I don't have to worry that I'm going to break the entire thing.
Yeah.
By trying to get that last 10%, I go back. There's none of this regression that I can incur. Obviously, I can regress, but it's a lot harder. And it doesn't feel like this big magic black box that, oh God, if I tweak this value, what's going to happen? And that's my fear. Nobody shipped anything on one of these systems yet.
No, I don't think they will. I think the tech is useful, only this level below.